Hey guys, so today we're going to go over a quick review about how to do sine and cosine graphs. So first thing to know is the basic shape each of these graphs take. So say you have the standard y equals sine of x, then that graph is going to look like, it's going to start from midline, go high, midline low, back to midline. And then if you have y equals negative sine of x, well, that's going to do the same thing, except instead it's going to go first to low, then high, back to midline. Then say you have y equals cosine of x. That's going to start high, go low, go back high. And then you have y equals negative cosine of x. It's going to do the exact opposite, start low, go high, back to low. So no matter what equation you're going to get for these graphs, they're all going to follow the exact same shape. So then you want to find the characteristics of the graph, and given the equation y equals a sine or cosine, does not matter, b times x minus c plus d. So to find the max, it's the absolute value of a plus d. And your minimum value is the same thing except negative absolute value of a plus d. Your amp, if there's no vertical shift or no d, it's just going to be the same as your max, but it's just typically absolute value of a. Your period is 2 pi over absolute value of b. And then your phase change is what's in the c. And then your vertical shift, if there is one, it can just be 0. And if it is 0, it's still going to apply, is d. So now let's actually solve for one of these problems. And like any standard graph, you want to solve for x and your y. Well, your y is right here. It's this huge equation right here. So you're going to plug it into this box in the chart. And this is already your y. But to get to y, you have to solve for the x right here. But how are you going to do that? Well, you're going to simplify this equation down until you get to the x. So you take away the most recent step to get to the previous one. So this one would be 2 sine of 3 times x minus pi over 2. Because then to get to this step, what you did is you just add the 4. So you simplify it down the line. So divide by 2, take away the sine, divide by 3. And then this will get you back to your x. And then in this box, it's the same thing as right here. So you take the step right before the trig function, and you plug in your standard values of 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi. Then you work left or right, whichever one you want. For here, let's just go to the right. So sine of 0, you know, is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And then sine of 2 pi is 0. Well, then to get to the next step, you already have the sine 3 times x minus pi over 2. That's already here, and all you have to do is multiply by the 2. So 0 times 2 is 0, 2, 0, negative 2, and 0. And then further, you just add the 4. So now you have your y coordinates right here. Then all you have to do is go back and solve for x. Well, to get to this step, you have to divide by the 3. And then once you're here, all you have to do is get back to the x. Well, whatever x is, to get to 0, you subtract pi over 2. So to get to the x, you have to add pi over 2. So 0 plus pi over 2, and so on. So then now you have both your x and your y, and you can plug that into your chart, labeling your points for convenience. Okay, so now to graph this. I've taken the points from the previous slide, just put them here for reference. And what you have to note is that between each of these points there's an interval of pi over 6. So pi over 6 is the interval of these tick marks right here. So each of the points is separated by that much. So now graphing them, you'll just graph it like any standard function. So the A will be here, it'll be C, D, and E. And now you have one full period of the graph. Also note that because the equation had a plus 4 at the end, the midline isn't the x-axis, but instead the line y equals 4. And now if you want to graph another period, all you have to do is follow the intervals to as many points as you need. So your next point would be point F, which would be at, well, if this is 7 pi over 6, your next interval would be 8 pi over 6. So 4 pi over 3, and it goes back to midline high, so at 6. So then your periods will continue this way and this way until you reach as many as you need. So now to find the characteristics of the graph, you can refer to the graph itself or to the equation. Both will give you exactly what you need. So your max value is your absolute value of a plus d, or in the graph you see that your highest point was 6, so it's going to be the absolute value of 2 plus 4, or just 6. Your minimum is going to be negative a plus 4, or on the graph it was 2. Your amp is the absolute value of a, and in this case it would not match up with the max. It would be 2. Your period is 2 pi over whatever b was, and b in this case is 3. Your phase change is what's in the c, so pi over 2. And your vertical shift, since we did add 4 to the end, is 4. Okay, so now all that's left is to find 5 alternative equations. So I've put up a rough sketch of the graph just as a reference for shape, and the 5 points that I want to highlight about how to write the equations for these. So you were given originally the equation y equals 2 sine of 3 times x minus pi over 2 plus 4. That's basically the same format you're going to follow with whatever point you're given, except you're going to replace the point with whatever point you want to use, and you have to adjust the trig function to match the shape. So say you want to base off your equation off of point F. Well, that's still going to be y equals 2 times, but watch where F is located. F is located all the way up midline high. So from high to low is the shape of your cosine graph. So it's going to be 2 times cosine of 3 times x minus whatever your x coordinate of the f is. So minus 4 pi over 3 plus 4. And then you're going to do the same with any of the points you want to use. So say you want to use point M. So y equals 2 times. M starts at midline, goes high. So it's also a sine graph. Except this time you start on the negative side. So it's going to be x plus pi over 6 plus 4. So you want to use L. Y equals 2 times, where's L? L is right here, up at high. So starts high, goes low. That's a cosine graph. So 2 times cosine of 3 times x, its x coordinate is 0. So you can leave it just 3x or minus 0 plus 4. If you want to use G, G starts at the midline, goes low. So y equals negative 2 sine 3 times the point x minus 3 pi over 2 plus 4. And then finally, if you want to use D, D starts low and goes high, back to low. So that's a negative cosine graph. So y equals negative 2 cosine of 3, plug in the point x minus pi, plus 4. One last thing to mention is just if you have an equation in this kind of format that you have the coefficients inside the parentheses, well then all you want to do is you want to factor it out so it's into the format that we're used to seeing more often. So then that's clearly your A, your B, your C. Technically this is your D if there's still nothing there. So I hope this video is helpful to clarify some sine and cosine graphs.